Welcome to Engineering Simplified. How does a washing machine know exactly when to let water in, with no human turning a tap? The answer is a solenoid valve, a simple device quietly controlling flow all around you. Let's break it down. A solenoid valve is an electromechanical valve. It uses electricity to control the flow of a liquid or gas, opening or closing a passage without anyone physically operating it. At its core sits a solenoid, a coil of wire that generates a magnetic field whenever current flows through it. That magnetic field is what actually does the mechanical work in this device. Inside the valve body sits a movable metal core called the plunger or armature, positioned right inside that coil, with a small spring holding it in its default de-energized position. When current energizes the coil, the resulting magnetic field pulls the plunger toward the coil's center. That single movement either opens or closes the valve's internal orifice, depending on the design. In a normally closed valve, the plunger blocks the orifice until energized, then lifts to let flow through. A normally open valve works in reverse, blocking flow only once the coil is energized. If you're enjoying this, like, comment and subscribe, and check out the other Engineering Simplified playlists. That basic direct-acting design works well for small orifices, but larger pipes need far more force than a small coil can practically generate to shift the plunger directly. For larger flows, engineers use a pilot-operated design instead. A small pilot orifice, controlled directly by the solenoid, bleeds pressure from one side of a larger diaphragm. That pressure difference across the diaphragm, not the solenoid itself, is what actually pushes the main valve open, letting the small coil indirectly control a much larger flow path. Solenoid valves also come in different port configurations. A two-way valve simply allows or blocks flow along a single path, acting as an on-off gate between one inlet and one outlet. A three-way valve adds a second outlet, directing flow to one path or another depending on its energized state. Useful for switching between two destinations, like diverting a fluid supply. These valves show up constantly in real systems. Washing machines and dishwashers use them to admit water. Irrigation systems use them to control sprinkler zones automatically on a timer. Pneumatic systems use them to direct compressed air to cylinders and actuators, while HVAC systems use them to control refrigerant or hot water flow through heating and cooling circuits. Response speed is a genuine advantage here. A solenoid valve can open or close in a fraction of a second, making it ideal for precise, repeatable, automated control sequences. Choosing normally closed versus normally open also matters for safety. Gas supply lines typically default to normally closed, so a power failure automatically stops flow rather than allowing it to continue unchecked. Coils are also rated for specific voltages, commonly 12, 24, or 120 volts in either AC or DC. Running one on the wrong supply can overheat the coil or prevent it from actuating at all. The common mistake people make is assuming every solenoid valve works by direct force alone, with the coil physically muscling open even a large valve against significant line pressure. In reality, most larger industrial solenoid valves are pilot-operated, relying on the system's own line pressure, redirected through that small pilot orifice to do the heavy lifting. That distinction matters practically too. A pilot-operated valve generally needs a minimum differential pressure across it to function correctly, unlike a purely direct-acting design. Without enough pressure difference, a pilot-operated valve may fail to open fully or close sluggishly, even though its coil and wiring are both working exactly as intended. So remember, a solenoid valve uses an energized coil to move a plunger, either directly operating a small orifice or indirectly operating a larger valve through pressure-assisted pilot control. From your washing machine to industrial process lines, that same basic coil and plunger principle is quietly switching flow on and off, precisely and automatically, millions of times a day. Drop a like, comment the topic you'd like to see explained next, and subscribe. It genuinely helps this channel grow. See you in the next Engineering Simplified video.